Hello everyone, my name's Tom Smetham and welcome to my channel. In this first video I'm going to be talking you through the basic concepts of compression using the standard compressor in Logic and showing you some of the extra features of the Logic compressor that will really help your mixes. I'm aiming this video at people who have a basic understanding of sound engineering and production. Maybe you're just starting out doing your first few projects as a producer, or you're a musician and you want to take your demos to the next level. I thought I'd start with a video on compression because it's a largely misunderstood concept. Many people just don't use it because they don't understand it, and others use it but don't really know what they're doing. So hopefully this video can address some of that for you. Compression is one of the two fundamental tools used by sound engineers alongside EQ. It is used to reduce the dynamic range of a signal, or in other words, reduce how much difference there is between the loudest and quietest parts of the audio. We can use it for a number of purposes. It can be used in more of a subtle way to even out the volume level of a recording that is too loud or quiet in some parts, for example. Or when extreme compression is used, it is more of an effect than a tool, resulting in a punchy, saturated sound. Before the invention of compressors, audio engineers would ride the faders on their mixing desks, pulling the fader down when it was too loud and pushing the fader up when it was too quiet. You can think of a compressor as simply automating this process. So we've got the Logic compressor here, and I'm going to start by talking you through the basic parameters of a compressor. Now while this is a Logic tutorial, you'll most likely see these controls on most compressors you come across. The first is threshold. Setting the threshold tells the compressor how loud you want the signal to be before it starts reducing the level. When the signal becomes louder than the threshold, it is reduced by a certain amount, controlled by the compression ratio. For example, a compression ratio of 2:1 means that for every 2 decibels the signal is louder than the threshold, only 1 decibel will be output. The next thing to understand is the attack and release controls. Attack and release determine how long the compressor takes to start and stop compressing the signal once the audio level goes above or below the threshold. The attack controls the time between the signal passing the threshold and the compression being fully applied. Similarly, the release controls how long it takes for the compression to stop once the signal goes back down below the threshold. It's really useful to understand how using attack and release times affect the sound, especially when working with transient sounds such as drums. A very fast attack time results in a snappy sound and more tonal changes of the compression are heard because the compressor is reacting so fast it squashes the transient itself. A slower attack time will let a transient pass before the compressor is fully working. Using this is great for adding weight to drums because you only compress the decay of the sound. In terms of release when using subtle compression, the aim is to set the release to follow the decay of the sound. A long release time, however, can be useful to create a pumping sound as the signal is compressed long after the level has dropped below the threshold. You can also see that on the Logic compressor there is an auto-release function, which tries its best to set the release to follow the decay of the sound. The knee is a strange concept to understand, but basically it smooths out the transition between the compressed and uncompressed signal. Instead of the compression being applied at the full ratio above the threshold, the knee smooths out this transition gradually, going from no compression to full compression the louder the signal is. You can see this by clicking the graph tab on the Logic compressor. As the level increases, the compression is applied gradually. This can be used to make the compression more subtle for when you want to control the dynamic range, but you don't want to hear as much of the tonal changes that compression causes. The last basic control is makeup or makeup gain. This is a simple level boost, and it's here because by nature, compression makes things quieter. The makeup is used to boost the signal after it's compressed to get it up to the volume it started at. It's also very useful to use makeup gain if you want some low distortion gain on a very quiet signal. You also have some options down the side here with gain. This allows you to automatically control the compressor to increase the gain to 0 dB or minus 12 dB on the output. I personally prefer to keep this off and set the gain myself, but it's there if you want to use it. Another thing I wanted to talk about is the meter here. It's really the most important thing to pay attention to when using a compressor because it tells you what the compressor is doing. This meter is called a gain reduction meter, and it tells you how many decibels of level reduction the compressor is applying. A good rule of thumb is minus 3 dB of reduction is a light compression, minus 6 is medium compression, and anything over minus 10 is heavy compression. So those are basic parameters you'll find on various combinations on most compressors you'll come across. As you can see though, it's not all the controls that the Logic compressor has to offer. You can see across the top here there are a number of switches, and these allow you to choose between a number of various different types of compressor circuit. These are great because, as well as the standard platinum digital compressor I've been showing you, these are all emulations of real life modern and vintage hardware compressors. I'll go over those in a bit more detail and how you might use them in a bit, but I'm going to show you this section on the right first. As you can see, we have two options here at the top, which are output and sidechain. I'm going to start with this output tab. The first thing we have is obviously your output level, but next to it we have a limiter. A limiter is almost the same as a compressor, except instead of reducing the output level smoothly by a ratio you set, a limiter does not allow the signal to be louder than the threshold. In fact, limiting can be defined as compression with a ratio of 20 to 1 or higher, and it's great for catching problem transients that your compression can't control. The next thing we have is this distortion control. This is used to add a bit of extra saturation to your signal, which is great for crunchy guitars or adding some drive to synths. I tend to use the soft distortion the most just because I prefer the warmer tone it has, but it's worth playing around and finding what's best for the sound you're working with. We also have this mix control down here, which allows you to blend your uncompressed signal with the compressed signal. This is what we call parallel compression. It's a really common technique producers use to blend the energy of a heavily compressed sound with the clarity and dynamics of an uncompressed one. Secondly, we have this sidechain option at the top. Sidechain compression is a technique where an external signal is used to control the compressor. This is commonly heard in electronic music, where a bass sound will often be sidechain compressed by the kick drum to give a pumping sound. You can choose the sidechain input from the source up in this corner. The lower section of this panel allows you to select certain frequencies to compress. This can be useful if, for example, with drum bus compression, where usually the kick drum dictates the movement of the compressor because it's usually the loudest. But if you don't want that, then you can use the filter to filter out the low end with this function. To do this, you use the filter controls at the bottom to select the type of filter, the filter frequency, Q, and for some filters there's an extra gain stage you can use. In a sense, this section works exactly like an EQ, except it's used to choose which frequencies you want to compress. This can be used to filter the audio input of the compressor, or when using sidechain, it will filter the sidechain input instead. The other section of the sidechain panel are these detection options here. These determine how the compressor responds to stereo sidechain inputs. With the max button enabled, the compressor will respond if either the left or the right signal exceeds the threshold, whereas the sum combines the signals and the summed level will activate the compressor when it exceeds the threshold. Also, these peak and RMS buttons tell the compressor whether you want the peak level or the average level to control the compressor. So those are all the controls on the Logic compressor. Now I'm going to take you through each compressor circuit and tell you a little bit about the strengths and weaknesses of each one. A lot of these are modeled on hardware compressors, and it's really useful to know what kind of circuit is best for different scenarios. That said, if you're interested in this, I'd urge you to just experiment. These are all great compressors and you'll learn a lot from trying new things. The default circuit is the Platinum Digital. Its aim is to be as transparent as possible, so it's great if you simply want to control the dynamic range of a performance. It can, however, sound a bit unmusical sometimes, and for me, I'll usually want a circuit that'll add a bit more character than the Platinum Digital. That said, if you want a very clean compression sound, look no further. Secondly, we have the Studio VCA circuit. This is based on the Focusrite Red 3 compressor. VCA stands for Voltage Controlled Amplifier. This is the circuit component which is used to compress the audio in the real thing, and it often tells us something about the characteristics of a compressor. The Studio VCA has a very transparent sound and therefore makes it very versatile like the Platinum Digital. It's a great option for your mix bus and sounds great on drum overheads and room mics to add the so-called glue that gels the whole kit together. Like the Focusrite Red, it also emits the knee control. We also have the classic and vintage VCA circuits modelled from the DBX 160 and the SSL bus compressor respectively. These circuits are more coloured than the Studio VCA, but have a great blend of colour and transparency. The vintage VCA is the most versatile of the VCA circuits, featuring all the same parameters as the Platinum Digital. The classic VCA, however, is a very simplified compressor without knee, attack and release controls, leaving just the threshold, ratio and makeup. This can be a really nice way of using our compressor though, and the simplified controls can sometimes help you focus on using your ears when you have more restrictions on the controls. The third category of circuit we have are the FET circuits, of which there are two. The Studio FET modelled on the Universal Audio 1176 Rev E, and the vintage FET modelled on the Universal Audio 1176 Rev H. The 1176 in general is one of the best known compressors out there, and they are a staple of the professional recording studio. FET stands for Field Effect Transistor, and they are characterized by having a fast attack time, making them ideal for transient heavy sounds. They also tend to be very colored, but they are great to get that high energy punchy sound. This makes them a go-to for drums and vocals. The two FET circuits don't differ that much, as you can imagine, apart from the vintage version having slightly more saturation than the studio version. The final circuit type is the vintage opto circuit. This circuit is based on the Teletronics LA2A, another legendary compressor. Opto is short for optical, as the LA2A uses a light and optical sensor to control the gain reduction. For its time, this design resulted in very clean compression, but by today's standards, it's heavily coloured. Nonetheless, its smooth musical tone sounds brilliant on bass, guitars and vocals. Due to its slow attack and release times, however, it's not the best choice for crisp, clean drum compression, but works great for a heavily driven, crushed drum sound. So there you have it. I hope this video has helped you either understand compression a bit better or given you some tips to improve your use of it. I've tried to stay away from specific instructions in this video because I know I learn best when I spend time finding out what sounds good to me, but there are some starting points here to put you in the right direction and understand what you're doing next time you're using the Logic compressor. Thanks for watching and see you next time. Goodbye.